I'm recording this. Okay. So I'm actually going to transfer this problem over here. Okay, so we know that's one solution we are not going to include. We had also talked about what those common denominators end up looking like. And if you take your denominator of the 2w minus 2 and factor it out, you can see 2 is going to be common between both our terms. So when you bring that 2 outside, you're left with w from the first term. And, of course, 2 goes into itself 1, so you're left with 1. So as you can see, our second and third denominator are basically 2 times the first denominator because it's 2 times w minus 1. So that actually ends up becoming your least common denominator, 2 times w minus 1, or, 2w minus 2, however you want to look at it. So now the idea is these guys are obviously good to go because they are both, the same as our least common denominator. So the only thing we need to do is multiply that first fraction by 2 so that we can have all 3 denominators be the same. So you will then end up with 2 divided by 2w minus 2 minus 1 over 2w minus 2, and then of course equal to 1 over 2w minus 2. So what do you think we should do first to try and simplify this equation? Or what can we do? So remind me of your name again, Luis, right? You're talking about moving a fraction to the other side, but even without moving it, what else can we do? Yeah, because you do have the common denominator in both those fractions. So instead of moving one fraction to the other side, you can actually combine those two on the left-hand side and, just make it into one single fraction. So since we already have that common denominator, remember that will stay the same, and all you are doing is a subtraction in the numerator. So 2 minus 1, of course, gives you 1. What type of equation do you think this is? So the left-hand side matches our right-hand side, right? 1 over 2w minus 2 equals 1 over 2w minus 2. Remember, we had talked about the different types of, this doesn't let me do that. Yeah, very nice. Remember how we had talked about identity, conditional, and inconsistent equations? So in this case, as you can see, when your left-hand side comes out to be the same as your right-hand side, that's when you run into an identity equation where we can say, all real numbers are going to be the solution with the exception of, no, 1. Yeah, because remember we said 1 was the number that makes our denominator 0. Now, if you had to simplify this further, if you wanted to take it all the way down to 0, 0, basically you can see all we would do is multiply, by our denominator on both sides. So then obviously these guys would cancel out, leaving us with 1 equals 1. You can subtract 1 on both sides and basically get down to that 0 equals 0, which is going to give us that true statement. But obviously, even at that stage where you have the fraction of 1 over 2w minus 2 on both sides, we know we have a true statement. So you don't have to go all the way down, but if you do need to get to that 0 equals 0, you definitely can. So remember, this is an identity, which means our solution is all real numbers except number 1. Okay, now this is something you're going to see later on, but I might as well introduce you to it, is what we call as interval notation. And this will be coming up, I think, later in this chapter itself. So interval notation is how you write it out, because otherwise you have to kind of write it out in a sentence like we did. Solution is all real numbers except one. So when we're saying all real numbers, we're basically saying you can go from negative infinity all the way to positive infinity and anything in between. So that will include fractions, rationals, irrationals, anything that you would think about as a real number. So when we are saying it's all real numbers except one, we're excluding one from that. The way you would write it out is we start out with the smallest numbers first in the interval notation, so negative infinity. Then we're going down to one, and remember, we're not including one. And since we're not including one, you put parentheses on it. Then we're going to pick up on the other side of one, right? So you go all the way to as close as you can get to one, but just not equal to one. And then you go on the other side. So again, we're starting out at one on the other side. And again, I'm using parentheses to show that I'm not including my number. And then we can go all the way to infinity. So since we're having to break this down into two intervals, for interval notation, we use this symbol, which is called a union symbol. So it's kind of like, you're adding, you're saying, okay, I have this interval, and then I'm combining it with this interval on the right-hand side. If I were to show this to you on a number line, just, what a real number line looks like. On the left-hand side, we go towards negative infinity. On the right-hand side, we go towards positive infinity. 0 would be in the center, and then somewhere to the right of that would be the number 1. So we're basically saying don't include 1, but everything to the right-hand side of 1 is okay, and everything to the left-hand side of 1 is okay. So that's where that interval notation is coming from. Negative infinity to 1, and then from 1 to infinity, you use the union symbol to combine them. So the difference with interval notation is you either use parentheses or brackets. So parentheses is for not including the number, brackets is for including the number. Now, you will see we have parentheses on infinity, and that's not because we are not including infinity. Obviously we want the all real number aspect of this solution, but infinity symbol is technically not a number. It's just telling us our numbers are getting really large on the positive side or really small on the negative side. So infinity is actually a symbol, it's not a number. And that's why we do not put brackets on infinity. So for infinity, positive, negative, you always, always, always use parentheses. Okay, so that's kind of how the interval notation aspect of it works out. Alrighty, guys, so that was your how to solve a rational equation that involves fractions. You've got a couple more examples over here. Now, I have worked all of these examples in our video lecture, so I'm not trying to be redundant over here, but I do want to show you some of the examples that I think would be important for you as you're going through your homework assignment. So I'm going to skip number 8, but I'll show you how to work number 9, because that involves a little bit of factoring. And I know sometimes factoring can be something, we need to kind of review or go over. So let's take a look at number 9 over here. Okay, come on, why are you not working? Okay, so number 9, we have 1 over x minus 3 minus 1 over x plus 3, and then other side you have x squared minus 9 as your denominator. So again, the first step is going to be to identify what numbers will make our denominator 0. And then finding the least common denominator. So let's figure out which numbers will make our denominator 0 first. And I'm going to do this on the right-hand side, sort of like scratch work. So of course, you can take x minus 3, set it equal to 0, which will end up giving us x equals 3 as one of those numbers. Same thing with the other denominator, x plus 3, set it equal to 0. And as you can see, that guy will end up giving us x equals -3. Now, what do you think we're going to get as our answers when we take x squared minus 9 and set it equal to 0? Yeah, very nice. Because of that square, you are going to actually get two answers. So obviously start by moving that 9 to the other side. You get x squared equals 9. But then, of course, to get rid of a square, we use a square root. Now, here's the thing you guys got to remember whenever you're working with square roots. And this will, again, this property is going to show up every time you use a square root. So since we are introducing a square root to get rid of a square, anytime you bring in a square root, you get one positive and one negative root. And I think that's where a lot of errors happen, is because we just naturally think it's all going to be positive, and that's not always true. Because remember, I can take -3 to the second power. So -3 times -3 also gives me +9. And of course, +3 times +3 also gives me +9. So you do have two roots that come out of this. So just be mindful of that. So you will end up with plus or minus 3. So essentially, you can see two numbers are not going to work in our solution, and that's +3 and -3. So x cannot equal positive or -3. Let's talk about our least common denominator. So of course, we've got x minus 3, we've got x plus 3. Now let's see what happens with that x squared minus 9. And this is where factoring is going to come into play. So if we take x squared minus 9, you need to factor that out. Now, I don't know if you guys remember this rule. We call it the difference of squares. So when you have a expression in the form of a squared minus b squared, which we do have x squared. And then if you think about it, I can write that 9 as 3 squared, right? 3 times 3. So it is in the form of a squared minus b squared, and a squared minus b squared factors into a plus b and a minus b. So using that same idea, this guy will factor into x plus 3 and x minus 3, which, as you can see, comes out to be those other two denominators that we had in there. So as you can see, my third denominator basically breaks down into a combination of, x plus 3 and x minus 3. And so that's why your least common denominator comes out to be x minus 3 and x plus 3. So that again tells me our last expression over here already has both those denominators, right? X plus 3 and x minus 3. But then these ones are missing the other pair. So here, the first denominator, we need to multiply that with x plus 3 so that we can get both of them in there. And then the second fraction will multiply by x minus 3. So I'm going to put these in parentheses. And I'm going to multiply this guy by x plus 3. Again, both numerator and denominator. And multiply this guy by x minus 3. Okay, so I know that's a whole jumble mess up there. So let's bring it down here. So this is what your first fraction should come out looking like. We have a minus sign here, and then for the second fraction, we multiply that by x minus 3. And then on the other side of our equation, since you already had x squared minus 9, I'm just going to put that in the factored form. But you don't have to multiply anything since it already had the original equation, denominator. Everybody with me so far? Anyone who has questions? Because this is a good place to ask questions. Yeah, go ahead.
Why don't we just put it as to the power two, plus, -9 and all?
The only reason I don't do that is in case towards the end, if I can cancel something out and simplify it, then it's better to do it in the factored form. But you know, sometimes they don't cancel out and you can go back and put it back as x squared minus 9. But just I like leaving it in the factored form just in case once I simplify it and something can cancel out, then it's easier to do it that way. That's the only reason. Awesome. That's a good question though. All right, so let's go ahead and see how we can simplify those numerators now. So of course, anything times 1 is the number itself. So this guy will just become x plus 3, you know, keeping that denominator as it is. Then we have a minus sign here. This guy, of course, will become x minus 3, and then right-hand side stays the same. Now, here's where you got to be careful, because anytime you have a minus sign in there, you know, it changes sign. So since we have this subtraction symbol right here in the middle, that's actually going to affect the signs of our second numerator, the x minus 2. So you know how last time we were talking about that distributive property with one of the examples we had done? That's kind of the same thing that's going to happen here, is you kind of want to think about that negative sign being distributed into your second numerator. So that negative will get distributed over here. So when we combine both of these, and now that we have a common denominator, you know, of course we can combine them. So our first fraction, x plus 3, but now since we're distributing that negative sign, it will become negative x, and then negative times negative will make it a positive 3. So go ahead and simplify that numerator on the left, and what do you end up with? Well, we're adding and subtracting, right? So you wouldn't really come up with x squared. So combine the x with the x, and, you know, of course, combine the constant with the constant. 6, yeah, because what's happening with the x? Yeah, very nice, because you have a positive x over here and a negative x over here, right? Louis, do you see that? Okay, I want to make sure. Oh, no, we're leaving the denominator as it is now. We're not messing around with it. Okay. So as you guys said, the x's cancel out. So you're just left with 3 plus 3, which of course then comes out to be 6. So what are we seeing here again, guys? It's a true statement, yeah. So again, you can't simplify this down to where it comes out to be 0 equals 0. However, in this case, your solution set, and you know, of course, this is again an identity. It's going to be all real numbers, but remember we had those two we could not use except -3 and +3. So in interval notation, when you're trying to write this out, again, I'll show you that with a number line first. So you will have +3 here, -3 here. So again, we're saying everything is okay except -3 and +3. So -infinity to -3, that interval is going to be fine. Anything between -3 to +3 is going to be fine. And you will see, again, I'm using parentheses on the -3s and the 3s, so that way we know we're not including those numbers. And then your last interval will, of course, go from 3 to +infinity. So this will break up into 3 different intervals when you have 2 numbers that you cannot use. And this is your interval notation. Questions on this one? Alrighty. What can you tell me about what you understand of absolute value? You can give me a definition, or you can just tell me in simple words what you understand about absolute value. Oh my God, that is perfect. Yes, absolute value is the distance from zero. And what happens when we put a number in that symbol for absolute values? I know you guys know the answer to this. So when we put our answer in those little vertical bars, that is a symbol for absolute value, what happens to that number?
No matter what project.
Very nice. No matter what number you put in there, it turns to positive, of course, except zero, because zero will stay zero. And that's because that is the distance from zero. So think about distances, right? We always talk about distances as positive numbers. You know, if you're going down south to Denver, you're not going to say, or I'm driving, negative 40 miles to get to Denver. You will just say, I go south to get to Denver, right? We always talk about distances as positives. And that's basically what you want to think about for absolute value also, because we're talking about how far is this number from zero. So when you look at this example over here, if we're talking about x, just as a random number, if we're talking about x already being a positive number, then when you put x into the absolute value, you will still get a positive answer. So positive will stay positive. However, if your x happens to be a negative number, then in that case, when you put it in the absolute value, it still comes out looking positive, because again, we're talking about, okay, so -3 is basically 3 units to the left of zero. So that distance is 3. It comes out to be a positive number. Now, how do we work with absolute value, equations when we're working with this? And let's take a look at an example here. You know what? Let's do number 12. Okay. Come on, buddy. Okay, so you have 5 plus 3, and then the absolute value of x minus 4 equal to 0. So again, just as a discussion, where would you start when we want to solve this equation? What would be our first step here? Okay, how would we do that?
You just go into like parentheses x plus 4.
So again, these are not parentheses, right?
Yeah.
So technically they are an absolute value symbol, but can we treat them like parentheses? I guess that's what you're kind of going for, right? Can we treat them like parentheses? No, you can't. So that's kind of why I picked this example here. So you have to isolate. Yeah, go
Do
ahead.
you multiply it or divide it on both sides?
So yeah, you do want to get rid of everything that is around the absolute value symbol. So you know how you try to isolate x in an equation? We're kind of going for that, but at the first step, you want to isolate the absolute value symbol. So we cannot distribute the 3 inside like we would do with parentheses. You start by getting rid of the 5 because that's an independent term. First, move the 5 to the other side, then get rid of the 3 and get that absolute value symbol by itself. So what we're trying to do is actually achieve what you had in that first example. You want to isolate the absolute value symbol and move everything else to the other side. So that's kind of what we're going for as our first step. So let's take a look at how we can do that. So like I said, get rid of the 5 first. So we'll start by subtracting the 5. Okay. We still have the 3 times our absolute value. Now, how can we get rid of the 3? Very nice. Yeah, so since you're multiplying, You can divide both sides by 3. And of course, you can extend that if you like. So this will now get us the absolute value symbol by itself, and then you have negative 5/3 on the other side. Okay, does anybody know what happens next?
Can you just drop it, like the absolute value? It's turn into x plus 4.
No, no. So with absolute value equations, because we don't know what direction this is going in, right? We don't know if you're going to the positive side or you're going to the negative side. Normally with absolute values, you do what we kind of saw over here, where you break up your absolute value into 2 scenarios. So anytime you are given an absolute value of, whatever number, doesn't matter what it is, you always set it up when you're solving these equations as once you can be going on the positive side of the number line, or you could be going on the negative side of the number line, because again, you can get multiple answers. One of them can be coming from the positive side, one of them can be coming from the negative side. So you will get 2 answers. Now, one of them may not work out, maybe it just doesn't give you an answer, maybe your x disappears, all of those things can happen. But when you're setting up an absolute value equation, you do have to set it up in those 2 formats. So you're technically dropping the absolute value sign, right? Like you were talking about, but you have to set it up as once with the positive a, once with the negative a. However, with this example, oops, let me clear this out. Where's my clear? Oh, there you are. Okay, let's clear this out. Come back here. Now think about this. We are saying you have a number over here that has a distance of negative 5/3. Can we do that? I have a number, doesn't matter what that number is, whatever it comes out to be, 0, 1, 5, 200, doesn't matter. Can a number have a distance of negative 5/3 from 0? Because remember what we just talked about, distances are always positive. You can have a distance of 0, which means you're at the starting point, or you can have a positive distance. You cannot have a negative distance. So this is actually telling us, because you have that negative on the other side, there is no solution to this absolute value equation. So please keep in mind, start out by isolating your absolute value symbol. So we got that absolute value of x minus 4 by itself. We moved everything to the other side. Just 1 second. If this guy was not negative, we would have solved it. But because this came out to be negative, that's the only reason why we're not solving. Go ahead.
I was just curious on what made you choose 5 first? Like at the beginning of the problem?
Like why you
Yeah.
subtracted 5,
Yeah.
because the 5 was independent of the absolute value, because this guy is 3 multiplied into the absolute value, right?
Oh, yeah.
So the first thing I had to do was get rid of what was not part of the absolute value. So that's why we chose the 5
That
first. Okay, good question. Yeah. Anybody else? Okay, so now that you've seen what to do when you have a negative on the other side and we cannot solve, let's go back to didn't mean to do that. Where's that guy? Number 11. Because if my memory serves me right, I think we do get an answer for number 11. So that should be a good practice for us. Okay. So this time you have 2 times absolute value of x plus 5, then you are subtracting 10 equal to 0. So same thing, right? Since the 10 is by itself, we'll start by moving the 10 first, and then we'll get rid of the 2. So let's start by adding 10. Actually, we didn't need to do that. Get that absolute value symbol by itself, So like we did in the previous example, now you can go ahead and divide by 2. And we now have absolute value of x plus 5. 10 divided by 2 will of course give you 5. So in this case, we do have a positive number and we know distance can be positive. So now we're ready to break it down into those 2 parts I was talking about. So this is where you will say, okay, x plus 5 can be on the positive side of the number line. So that's equal to positive 5, or x plus 5 could be on the negative side of our number line. So this will be equal to negative 5. And this is always going to be true whenever you are solving an absolute value equation, as long as you have a 0 or a positive number on the right hand side. Okay? Because the distance of 0 is still a distance, right? Like I said, you're just at the starting point, but it's still technically a distance. All right, so what's the 2 answers you come up with from each one of these equations?
0 and -10.
Okay, let's check that very quickly. So we start by subtracting 5. Well, for both equations. And then 5 minus 5 will of course end up giving us 0 here. And yeah, very nice. This will give us -10. So your solution set. And this word just flew out of my mind. It's not interval notation because we're only saying these specific 2 numbers are our solution. So only -10. It'll come back to me. But anyway, so this is not an interval notation, right? We're not saying you can go from here to here and everything in between. We are saying specifically only -10 and 0 will satisfy our original equation. So that's why we're using these, I don't know, curly brackets. I'm going to call them that. I'm sure there's an official name for it.
Called the contradiction
What do you mean?
is like the solution set, that answer called a contradiction.
No,
No.
not a contradiction, no. And this would be actually part of the conditional equation that we had talked about, because we're saying it's not all real numbers, but you do have specific answers that satisfy. So this will be part of the conditional, because apparently so far we've only seen that identity example. So it's kind of nice to see a little bit of a different one. We did, of course, see the inconsistent equation with the previous number 12, because we didn't end up with a solution on that one. So that was an inconsistent equation. All right, wonderful, guys. Let's see. This is an example for a linear equation. They're just kind of using it in an application just to show how you would, adapt equation solving to an application problem over here. So this one is actually a pretty straightforward problem. They're telling you if X is the number of years after 1990 and Y is the median income for working women in the US, then the equation that's given to us, Y equals 355.9X plus 11,075.3, will model the real data. So they're basically saying, okay, we know X is going to represent the years since 1990. So, whatever year they asked us to go for. Y will represent what the median income for women is in the United States. They want to know in what year, to the nearest year, so rounding it up to, not a decimal, but to a whole number, what will be the median income, or sorry, in what year will the median income reach $25,000? So any ideas how we would go about finding the year?
Would you put like the 25,000 into the Y and then find out what X is?
Very nice, yeah, because they're telling us Y represents the median income. 25,000 is the median income, so you're putting that for Y, and since X represents the number of years, you're solving for X. All right, so let's take a look at what this guy will come out to be. And since you have decimals and stuff in here, you definitely want to use a calculator to break that down. Oh, speaking of calculators, I stopped by the Learning Commons on my way in, and they only have one calculator that they can let you borrow. So I need to email my department chair and see if we can get Learning Commons to send down more calculators, because that's just not, that's just to me a joke that they only have one to rent. I know they used to have more, but I guess over the pandemic, things have disappeared. So I will make that request, but unfortunately, as of now, they only have one that they can rent. So if you guys can bring your own calculators, obviously that saves you that trouble. Okay, so that's kind of where we are at. So we're plugging in the 25,000 for the Y value. Oh, didn't mean to do that. And then you have 355.9x plus 11,075.3. So I'll give you guys a couple minutes to work through this. And then let's compare the answers you come up with. Additionally, remember the X value that you're going to get is just going to be the number of years, right? You do have to figure out from 1990 when that year will be. Because they want to know specifically in which year, in what year does that median income reach $25,000. So don't just give me the X value, tell me from 1990 what year you're landing in.
Thank you, Nancy, maybe.
1990, yeah, that's the that's when the X begins. Do you have an answer?
And then, so did I.
Yeah.
2029, are you guys making sure you're rounding correctly?
Should.
I know.
That's 2031.
Yeah, I rounded down. I didn't round up. So did I.
Wait, thanks for keep it at 39 to.
You're getting, it looks like 39.1.
128.
128.
I got 125. Just 125.
They still wouldn't round up, we'd still.
I usually go off.
That can be, let's see. Okay, so. Okay, I've got that divided by. Okay, so the decimal part comes out to be about 1.5 months. So yeah, I think it's okay to round down. I don't think in a month's time we're gonna make a whole lot of difference. So yeah, if you're getting 39.128, I think you said you had 125 on your paper. So yeah, you can round down the years. And then based on that, it looks like you said 2029.
Yeah, so
And I think that's what you had. Did anybody get it? You had 2031. Can you tell me how you came up with that?
So I've subtracted 11,075.3 on both sides,
Yeah,
the X by itself. Then I divided 355.9 on both sides,
okay. And what did that X value come out to be?
41.45.
Hmm. Okay,
So then I rounded down.
so. All right, so when we do this little subtraction over here, it's coming out to be 13,924.7. Yeah, and then you divided it by 355.9.
Yeah.
To get our X by itself. Okay, 355.9. And see, that's where I'm coming up with the 39. I'm not sure what gave you the 41. Because this is what my calculator is showing, the point
Yeah.
3161, and then since this is 39 years from 1990, you just add that 1990 to that. So we're basically saying in the year 2029, median income for women and we're talking about a median income over here. If you think about averages, we're talking about an average over here. And I think that is, really sad. If you think about the median, the average income for women will be another, 7 years from now at only $25,000. I mean, talk about income inequality, and you can go to that website and see what the average income for men is. And this is something very real, I mean, can anybody survive on $25,000, especially in states like Colorado or California, which are super duper expensive states? I can tell you on my income, I can't even buy a house. So that is really, really scary to think about. That's the median income, and I'm a single woman, but what about people who have kids, families? If you're a single mom, you cannot survive on that. And so this is just a simple example just to show you how you can take the information you have. And of course, they've given us the equation, which makes it easier for us. But we will get into examples later on where they'll give us the situation and then we have to come up with our equation. But obviously by that point, you guys will be more comfortable coming up with your equation. They obviously didn't share a whole lot of background information with us since they're giving us the equation. But as you move forward, you will definitely see, sometimes this tablet really doesn't want to cooperate with me. Okay, don't do what you want to do. All right, so here we're getting into constructing our models. And this is going to be based off of information that we already have. So, formulas that we know, situations that we are familiar with. So based on that, then we will be able to come up with, formulas for the specific problem that we are working on. So they're talking about, well, I mean, you've got your definition for a formula there, but something like distance, rate, and time. You have the D equals R times T, or if I remember this correctly, I think if you remember dirt, then that kind of helps you remember the combination here, so DRT. Of course, we have area formulas. So for a basic rectangle, it's length times width. For a square, that would be side times side. Parallelogram is base times height. So, if you can use some of these known formulas, it can help you come up with an equation once you get into solving these problems over here. So the example we are looking at, my fat fingers are going everywhere. Let's see, this one is just actually asking you to rewrite the formula. So, instead of D equals RT, what if we wanted to get R by itself? So what would you end up doing to get R by itself? Yeah, very nice. So in here, to get R by itself, we would basically divide by T on both sides. Right? You can cancel out the T and you end up with D over T equals R. For that matter, if you wanted to get T by itself, we would divide by R on both sides, right? So this is just about rearranging your formula. Same thing happening on example 2, where they're asking you to get Y by itself. So if you're trying to get Y by itself, where would you start first? What should we get rid of first on the left-hand side? Yeah, get rid of the AX. So we go ahead and subtract that AX. You're left behind with BY equals C minus AX. And then to get the Y by itself, yeah, see, there you go, divide by B. And as you can see, we will end up with Y equals C minus AX over B. So as you can imagine, this little exercise is basically just so that, once we do come up with our equation, depending on which variable we are solving for, we should be able to rearrange our formula and basically solve for the problem that we're trying to solve for. Okay. All right, I'm going to clear this out. This one is pretty straightforward. I actually want to get into the word problem. So as you can see, they're giving you the value for A. They're giving you the value for H over here. Let's see, they're also giving you the value for B2. So as you can see, they're giving you 3 out of the 4 unknowns, and they are asking you to find B1. So as you can imagine, you would plug in your numbers, work backwards to solve them. Again, you guys can do this on your time just to see how that would work out to be. It's part of your video lecture if you want to see, but I do want to get into constructing our own example. So let's start with number 4 over here. This one is talking about the saddle height on a bicycle should be 109% of the inside leg measurement of the rider. What happened to my? Oh. Trying to see if I can find the figure for you so you can kind of see what this looks like. Ah, there we go. Leg measurement, so that's that distance we're talking about here. If the saddle height is 37 inches, then what is going to be the inside leg measurement? So, of course, as you can see, there's no equation here. We have to come up with our equation. So how can we come up with that equation here? The saddle height on a bicycle is 108% of the inside leg measurement. That's where you're going to find that equation.
So we're using, wire that I'm thinking,
Sorry?
we're using wire that I'm thinking.
So a form of that, but not entirely the same. Because it's going to be something like that. You're just not going to have the plus B part of it. Okay, so let's first come up with our variables. Now you can obviously use X and Y as your generic variables, or since we're talking about saddle height here, we can say, okay, the height is going to be H. And then they're telling us the inside leg measurement is what we're trying to find. So I don't know, we'll call that L. So they're telling us the saddle height should be is basically is the saddle height is 108, not 1008. 108% of the inside leg measurement. Now, if you guys, and this may have been a long, long while for you, but if you remember the basics of equation forming, is always represents the equal to sign, of represents multiplication. So that's basically what we're doing. This should be, like I said, think of it as is. So that's going to give you your equal to, that's where the saddle height equal to 108% of, so that's the multiplication, 108 times whatever the inside leg measurement is. We need to convert that 108% to a decimal. So what will that be as a decimal? Yeah, very good. We always convert percentages to decimals when you're solving them, in these type of examples. So your equation will come out to be H equals 1.08 times L. Okay, so now with the second part, with the information given, where do we put those numbers in and what we're trying to find? If the saddle height is 37 inches, then what is the inside leg measurement? So for which variable will that 37 inches go for? Very nice. Saddle height is 37 inches. So you end up with 37 equals 1.08 times L. So what will you end up getting for L? And they're asking us, if you look at the little blue in here, they're asking us to round it to the nearest 10. So that's another thing you guys should be paying attention to when you're working on homework, is underneath the answer box, usually in the blue, they'll give you instructions of, if there's rounding or whatever, can you put it as a decimal? Can you put it as an integer? Those kind of instructions will be given to you. Oh, bless you.
Thank you.
Anybody have an answer for inside leg measurement? Yeah, 0.2, yeah, 0.3. Anybody get a different answer from 34.3? Okay, so obviously, since you are multiplying the 108 into the leg measurement, you will obviously end up dividing both sides by 1.08. And the raw answer is coming out to be 34.2592, and it keeps going. So rounding that to the nearest 10th is 34.3, and this will of course be in inches. Come on. What? Alrighty, check our answer. We should be good to go. So again, like I said, some of them, kind of, you can use the distance, rate, and time formula, if they're talking about a problem related to that. Your area formulas, if they're talking about something like that. In this case, there was no known formula, but the statement itself was giving you the relationship between those two variables, which was that first statement over there. And based on that, you had to come up with your example, or your equation. Not you. This one over here is talking about doing laps, a racetrack. So Bobby and Rick are in a 10-lap race on a 1-mile oval track. Bobby is averaging 90 miles per hour and has completed 2 laps, just as Rick is getting his car onto the track. What speed does Rick have? What speed does Rick have to average to get even with Bobby at the end of the 10th lap? So Bobby is averaging 90 miles per hour. We already know he's 2 laps in. And we know this is a 10-lap race over a 1-mile track. And we need to know, since Rick is starting 2 laps afterwards, what would his speed need to be? What would his average speed need to be? so that he can be even, at the end of those 10 laps. So just thinking about that, does his speed need to be faster or slower than Bobby's? Faster. And the hint they're giving us is Bobby does 8 miles in the same time as Rick does 10 miles, because he's already done the 2 laps, so he's already 2 miles ahead. So that's your hint over there. So this is coming from the DIRT formula, distance equals rate times time. How can we use that to come up with the equation for this example here? So take a minute, think about it, see what that hint can do to help you set up your equation for this guy. So distance, rate, and time. Maybe you want to start out by creating the columns and see, okay, what of those 3 variables do we know for each of the drivers? What information do we have? So what distance does Bobby have to travel?
10 miles.
8, right? Because he's already 2 miles ahead. So he is traveling 8 for Ricky's 10 miles. What do we know about their rate or speed? 90 for Bobby, right? And about Rick? That's what we're trying to find, right? So that's our unknown, and you can call it X. What can we say about the time? It's 2 laps ahead, so he's kind of got a head start on that. But they are finishing together, right? Because that's kind of what they want us to figure out is for the 8 miles that Bobby does, Rick has to do 10 miles, but they are telling us they want it to be even at the end. So that actually tells us that they're going to keep the same time. The one guy has to just go faster to, catch up and be even with the other one. So that's actually where this equation is going to take a turn. So the time is actually going to come out to be the same for both of them. Come on. Okay, so since the time is going to be the same for both, you are actually going to rewrite this equation by getting t by itself. Since both of them are going to have the same time, we don't have to worry about the time, and we are going to set up our equation in the form of distance over speed, or d over r. So the way we're going to do this is, since both of them have to finish in the same time, that's going to be the general form of our equation. So we know Bobby has to do 8 miles, and he's going at a speed of 90 miles per hour. Rick has to catch up and do his 10 miles, and we're trying to figure out what his average speed is going to be. So that's actually where that setup comes from. 8 over 90 equals 10 over x. So distance on the top, both the speeds on the bottom. So now that we have our equation, how do we go about simplifying it? What's the key word I'm looking for here? How do you solve an equation in this format? I thought I heard something. Like on both sides?
You do like,
No.
like, don't you do?
Yes, that's what I was looking for. Was that what you were
I was
gonna say?
that.
Yeah, so yeah, cross multiply is what we're looking for, and it will actually end up flipping your equation. So you're going to multiply, as the name suggests, cross. So you will then end up getting 8 times x on one side and 90, I was gonna say 9 times 10, but 90 times 10, which of course comes out to be 900, right? So you can see, once you get that basic set up, then, just finding your unknown value is not the big part, but just making sure you're coming up with the right equation is the more important part over here. So what do we think the average speed for Rick will come out to be?
112, almost 113.
Yeah, so divide both sides by 8. And 900 divided by 8 came out to be 112.5 miles per hour. And again, just look at the rounding rules that my math lab will have. If they want you to keep it at a decimal, they want you to round it to a whole number. But obviously you can see that's a significant increase in the speed going from 90 for Bobby to 112, 113 for Rick, because he does have those 2 miles to catch up, but obviously still maintain that same pace so that they can both end at the same time. So just again, laying back on known information to try and simplify a problem like this. So you will see there's a bunch of different examples over here. This one is talking about fencing off, I think, a yard, feedlot. This one is what we call as a work problem, and then a mix of a solution. So instead of doing this one over here, let's pick one from your homework. Similar to what you have in the handout, but we'll just go with this one here. So this is talking about a carpenter used 34 feet of molding in 3 pieces to trim a garage door. If the long piece was 2 feet longer than twice the length of each shoulder piece, how long was each piece? And I know that garage door is kind of hidden a little bit over there. They're talking about trimming it in 3 pieces. Obviously, those top and then the 2 side edges are what we're talking about. They're calling that shoulder distance as X, so you can definitely stay with that. So we know they have a total of 34 feet of molding cut into 3 pieces, and they're telling us the long piece is 2 feet longer. So that's going to be this long piece over here is 2 feet longer than twice the length of each of the shoulder pieces. So if the shoulder piece is X, so both of these side measurements would be X, what expression or what term can you come up with for that long piece if it is 2 feet longer than twice the length of the shoulder piece? Very nice. So it is twice as long as the shoulder piece, plus it is 2 feet longer. Very nice. Okay, so we know what the 3 sides are going to be. X and X for the shorter ones, 2x plus 2 for the larger one. So now what do we do? What will our equation end up looking like? We know that he's using or she's using 34 feet of molding. Anybody here does carpentry? I'm too scared to lose my fingers, so I do not go near those tools, but I would love to build something on my own. I think that would be such a huge accomplishment for me. 34 feet of molding. This person is trimming 3 sides of the garage. We know in general, generic terms, what those measurements should be. How do we put it all together to make our equation happen? I know somebody's got it.
I'm gonna throw a ball here.
Sure.
Like 34 equals 2x plus 2 to the, and then multiply x squared.
Oh, it's so close. No, it's not multiply. Add, yes, because 3 pieces, right? All of them have to total to 34 feet. So you're just adding all 3 sides of that trimming to get a total of, think about perimeter. This is a perimeter problem, right? Like if you were putting a fence, which is I think what we're doing in the handout example, if you're putting a fence around a garden, let's say, it would go on all 4 sides. So that's your perimeter. We would add that. If you're laying a carpet or, if you were laying grass, that would be covering the area. That's area. So if you're painting a wall, that's area. If you're going to put a trim like we're doing here in this example, that's a perimeter. So you add all 4 sides. But in this case, obviously we're not putting the trim on the bottom part of the garage door. So that's why you're only doing 3 sides instead of 4. So your equation then comes out to be, we know we have a total of 34 feet of molding. We have the 2 shorter sides, so x plus x, and then our longer side, 2x plus 2. So then combine your like terms, get x by itself, and I'll again give you guys a couple minutes to simplify, and then let's see what you come up with for your x value. And as you can see, they actually want you to find the length for both the shorter side of the garage trim and the longer side. So once you get your answer for x, you still have to come up with what the longer piece and the shorter piece for the trim will be. So the x is not your final answer. So what's the length of your shorter piece? 8. Longer one?
So the 2 shorter ones go up to 16 and the longer piece.
Okay, but that would be 8 each, right, for the 2 shorter pieces? And so that has to add up to 34. So that's a good way to check and see if your math came out to be correct or not. So yeah, you can see we have 1x plus 1x plus 2x, right? So 1 plus 1 plus 2 will add up to 4x. So this guy will come out to be 4x plus 2. And then of course 34 on the other side. So we will start by subtracting the 2. Which will then end up giving us 32 equals 4x. Divide both sides by 4. 4 goes into 32 8 times, and that 8, which will be feet, is the measurement of your shorter sides, right? So your shorter side comes out to be 8 feet long, and as you said, double that and it's 16. So that's going to be 16 for the 2 side edges. And then the longer piece is the 2x plus 2. So that would be 2 times 8, which would be 16. 16 plus 2 would be 18, and I think that's what, Louis, you told me. So now think about it, if you do 18 plus 16 for the two shorter sides, it adds up to 34, right? So you know your measurements come out to be correct, so just have to plug these numbers in. The long piece was 18. Shorter one. And they just want one single measurement for the short one, so you'll be putting an 8 in there. Let's check our answer and we are good to go. So this one again was coming from a known formula, which is technically the perimeter of a rectangle. But like I said, instead of going for all four sides, you're skipping that one side because they're only trimming 3 sides of your garage. And as you will see, you know, for some of these examples, they have the illustration, but if they don't, just draw a simple illustration so you can kind of visualize, you know, what they're talking about. And I think that really makes a huge difference when you're solving some of these, you know, word problems. Okay, so this is what we call as a work problem, and there's many different ways that you can set this up. I just picked a goofy example here about Batman and Robin, I think, fighting crime in Gotham City. But the idea is, you know, we're talking about a job getting done, right? If one person does it, it takes them this long. If you bring in 2 people, you know, you will get it done faster. So they do these types of examples with like machines. So, you know, if they're saying, oh, if we're, you know, filling a pool, a swimming pool, you have one pump that takes so long to, you know, fill up the pool. But what if we bring in 2 or 3 pumps? You know, of course, the job will get done faster. So how long would it take, you know, to get that job done? They can do this with, you know, I've seen examples where they're talking about raking, you know, fallen leaves, typing up some kind of reports. If one person has this speed, you know, they do it so fast. How much long will it be if we get more people? So there's many different formats, but the setup is very, very similar for all of them. So this one is talking about Batman can clean up all the crime in Gotham City in 8 hours if he's working alone. Robin can do the same job in 12 hours. Obviously, he's a little bit slower, takes him a little bit longer. So they're saying if Robin starts crime fighting at 8 a.m. and Batman joins him at 10 a.m., at what time will they have all of the crime cleaned up? So in this case, they are giving you a little bit of that, you know, the slower person starts out earlier, and then the other one who works a little bit faster joins him. But a lot of times they may not even have the different time difference. They may just say, you know, Batman takes 8 hours, Robin takes 12 hours. If they start working together, how long will it take? So sometimes that time difference is not there, but it's in this one. So how can we set this one up to try and break it down? So, you know, we're kind of talking about how fast a person works to get a job done and what happens if we put 2 of them together. So any ideas on what we can do for this example here? Anybody?
Use a third again.
Sorry?
Use third again instead of something that is-
Kind of, but you know, obviously we don't have the whole distance issue in there, but we are kind of talking about how fast a person works and how long it takes them to come up with. So we know Batman does 8 hours and Robin does 12 hours. So the idea is to get a job done, you know, and it's one job, the one single job, which is cleaning crime in Gotham City, right? So you come up with the speed of that person. So if it's taking them 8 hours to get the entire job done, then a fraction of that would be 1/8. If it's taking them 12 hours to get the job done, then the fraction of that would be 1/12. So the way we set this up, and they're asking us, at what time will they have all of the crime cleaned up? So the question is at what time. So if they're starting at 8 a.m., you know, is it going to be noon? Is it going to be 5 p.m.? You know, that's what we're finding. But technically, you're finding how many hours it's going to take them. And then based on how many hours, then we can figure out what that time is. So of course, our unknown variable here is going to be time. And it's actually going to start out with, I would say, since Batman is starting 2 hours after Robin does, let's say T is the time that it takes Robin to get the job done. And then from that T, we will just subtract 2 to accommodate for Batman starting out 2 hours later. So I think that would be a good start for this. So let me get my notebook over here going. Ah. There we go. Okay, so let's see, this guy is. So it's going to be a little bit different from the DIRT formula, but we are using that same concept of rate times time to come up with our equation here, if I can get this to work. Okay, so Batman is 8 hours. Yeah. Robin was 12 hours. Okay. So like I said, his rate would then come out to be 1/8. And for Robin would be 1/12. The time would be, for Robin, we are saying it's going to be T hours, however long that takes. And since Batman came in 2 hours later, his time would be T minus 2. Now, for these work problems, as they are called, you will take the rate multiplied with time. So again, kind of like that D equals RT, but we're not really calculating a distance in this case. We're just saying it's rate times time. So for Batman, of course, that would be 1/8 multiplied by T minus 2. Since they're working together to solve this crime, you add them. So 1/12 times T, and they are doing one job, one work. So it equals 1. That's the general setup for these work problems. You take the rate of how fast a person works with how much longer it's going to take them to get the job completed. Same thing for the other person. What is their speed, what rate they're working at, multiplied with the time it will take them to get the job done. And like I said, they're doing one job. It's, one thing, so it's always going to be equal to 1. So that's where your setup begins. So if I had to clean this up, multiply the numerators, you would get T minus 2 over 8 plus T over 12 equals 1. So of course, we need to start out by finding our least common denominator over here. So between 12 and 8, what kind of common denominator are we looking at?
4.
Okay, so it's got to be a number large enough that 8 and 12 will divide into it. So what you guys are actually giving me is the greatest common factor, like what number is common between them, but we're looking for a number large enough that both of these will divide into. Yeah, very good. So the clue for that, I would say, is start with the larger denominator and go through the multiple. Now 12 itself, 8 cannot divide into 12 evenly. So then we go, okay, what's the next one? 12 times 2, 24. And yeah, 8 goes evenly into 24. So our least common denominator will come out to be 24. So there's 2 ways you can solve this. You can multiply the first fraction by 3, multiply the second fraction by 2, and then multiply on the right-hand side by, 24 over 24. Or since this is an equation, you can take the entire equation and multiply by 24. So what that does is actually helps you get rid of fractions altogether. You don't have to worry about the denominators anymore. So you take each one of these terms in your equation and you multiply it by that LCD of 24. So you will end up getting 24 times T minus 2 over 8 plus 24 times T over 12 and 24 times 1. So as you can see, 8 goes into 24 3 times, 12 goes into 24 twice, and then of course, right-hand side, you'll just end up multiplying them together. Now be careful, you do have T minus 2, which is an expression. So if it makes it visually better for you, put it in parentheses. So you will know we need to distribute that 3 inside T minus 2. But you will see now we don't have any fractions to worry about. 2 times T on the other one, and then 24 times 1 will give you 24. Distribute that 3. What will that give us? 3 times T minus 6? Now remember, T itself represents how long it will take Robin to get the job completed. And it should be less than 12 hours because Batman obviously came in to help him out. So if that number comes out to be larger than 12, then obviously something went wrong. So just keep in mind, it's got to be less time than when they were working alone. So let me see what your T value comes out to be. And then officially your question is what time do they get done? So that remember, I want to keep saying Batman. Robin started at 8 a.m. So you're taking the time you came up with, add that to 8 a.m. and that will tell you when they get done with their job. Okay, so you're saying 2 p.m. And you can of course verify that with Batman's time, just subtract 2 from the T and then add that to his time and you'll get, they should be done at the same time. So what's your T value coming out to be? 6. So we're saying it's going to take them 6 hours, which is half the time it would take Robin if he worked by himself, right? So of course you can combine the 3T with the 2T. 3 plus 2 will give us 5. You have the minus 6, so go ahead and move that guy to the other side. So that adds up to 30. 30 divided by 5. That's where your 6 hours comes from. So for Robin, who started at 8 a.m., he would end at 6 hours later was 2 p.m. Batman started at 10 a.m. So remember, for Batman, you would do T minus 2. So it only took him 4 hours, right? Again, half his time. So 10 plus 4 hours would again put you right back at 2 p.m. So they should be done. Yeah, what time did they get done? It was at 2 p.m. So be mindful again of what the question is. They didn't ask you how many hours it's going to take them. So 6 hours would not be the right answer. They want to know specifically what time. So just those little tiny things, will make a difference. Any question on the work problem? Okay. Okay, so we're at 12:47. Make sure that I stay on track with our time and don't get too carried away. Let's do the chemical mixture problem over here. So this is, you're mixing 2 different concentrations or diluting something. And what does the concentration of the final product come out to be kind of situation? So they're saying, how many gallons of a 90% antifreeze solution must be mixed with 70 gallons of 20% antifreeze to get a mixture that is 80% antifreeze? So you can see we're taking a high concentration, 90%, mixing it with a low concentration of 20% antifreeze. So, of course, you're taking something which is very strong with something not quite as strong. So when you mix them together, your concentration level is going to come down. It's kind of like how you mix water with something to bring the concentration level down. So at that point, you will be getting 80% antifreeze. So the question technically is how many gallons of the 90% should we have? You're adding 70 gallons to that, which will lead you to your final product over here. So, of course, the first things you're going to do is convert all your percentages to decimals, because then that concentration is going to be combined with how many gallons of that liquid you are using. And let me make sure I'm doing this right. Okay. So let's look at just to compare, this was from your handout. So this one was, oops, your 70% alcohol. So they're saying a pharmacist needs to obtain a 70% alcohol solution. How many ounces of 30% alcohol solution must be mixed with 40 ounces of an 80% alcohol solution to get a 70% concentration. So similar kind of example, they're just talking about antifreeze over here instead of an alcohol solution. So we don't know how many gallons of the 90% we're going to use. That's our unknown value. So we can call that X. 90% as a decimal. Very nice. 0.90. They're telling us it's going to be mixed with 70 gallons of 20% as a decimal. Very good. And our result is going to be a mixture of 80%. There you go. Now the mixture, how many gallons will the mixture be? You're not cooking anything, there's no evaporation. It's a mixture of the two liquids put together. I know you guys. Well, we don't know the number, but we need to come up with the expression. So you're mixing the 90% concentration with the 20%. Greater than 70, and how can we come up with that? There you go. That's what I was looking for. So 70 gallons of the 20% concentration plus whatever that X value comes out to be for the 90% concentration. Okay, so we know this is a mixture. That's where your equation is going to come from. So we're taking the 90% concentration. How many ever gallons of that? You're mixing it, which means you're adding it to the 20% concentration, which was 70 gallons of liquid. And that will give us an 80% concentration of, whatever that total comes out to be. So again, not a known formula, but you can kind of see how if you just follow this concept of I'm mixing two things, so we know 70 plus X will give us whatever the new mixture quantity is. And now you just have to figure out with the concentrations how it's going to be. So you multiply the concentration into the quantity. So let's clean this up before we can get our X's together. So of course, 0.90X will stay the same. Let's multiply the second one. So 0.2 into 70 gallons. 14, right? And then on the other side, you will need to distribute that. So 0.80 times 70, what will that give us? Yeah. Plus, of course, your 0.80X. Okay, get your X on one side, get your constant terms on the other side, and let's see what your X value comes out to be. Okay. Just trying to make sure my math was right. What did we get for X? Okay, good, because I was like, that just seems too much. Oh, no, no. Okay. But if you think about it, it does make sense why that number works. Because your concentration is not going down a whole lot. You just went from 90% to 80% in the mixture, right? So it's not like you went down all the way to 50% or something. So if you think about it, it makes sense because you're only putting 70 gallons of this 20% antifreeze, and you're keeping the concentration at 80%, which means you had to have a lot of that 90% that you're only bringing it down by 10% by mixing in this diluted, liquid in there. So 420 actually is reasonable when you kind of put it in those terms. So let's do a quick check over here. Good to go. Alrighty, so this was basically section 1.1 and section 1.2 that we got done with today. And so hopefully you guys have enough to get started in chapter 1 assignments also, but obviously, as I mentioned before, make sure you're working on those chapter P assignments as well. I would say do chapter P for a while,